Welcome back, guys. Yes, we will be doing this time verifying credit or debit cards. Now, it's just that I won't tell you what bank owns this algorithm because, of course, for security purposes. So, yeah, let's have an example here and let's check if this credit or debit card is legit. You have the number 2345-3271-6789-1008. Now, just like UPC algorithm, we have a multiplier in verifying credit or debit card, and our multiplier here is 2. And same as UPC, this multiplier will be multiplied to the numbers in odd positions. So let's separate our the numbers in odd and even. All right, so let's have here odds. Okay, and for visual learners, let's highlight those numbers in odd positions. That would be the numbers 2, 4, 3, 7, 6, 9, 1, and 0, which would be the first, third, fifth, seventh, ninth, 11th, 13th, 15th digits. Okay, so there. As I said, the multiplier would be 2. But unlike with UPC that we can do this type of technique like 2 times 2 plus 4 plus and so on. If you are verifying credit or debit card, we won't be using this technique because we have an added security tweak in this algorithm. That is, in the event that the product would exceed 9, meaning the product would be 2-digit, then we would split it 2-digit and have to add the numbers in there. Now, for visual learners, let me have that one here. This is the one that I am talking about. Like, since the multiplier is 2, and that would be multiplied by 2. Next, 2 would be multiplied by our 4 here. Next 2 are 3 and 7. Next would be 6. And next would be 8. 1, and lastly 0. So again, you may opt out writing 0 because the answer will just be 0, and anything added to 0 will just be the number itself. But again, for visual learners, let me have that one here. Okay, so this is the one that I mentioned earlier. If we are doing or verifying credit or debit card, the products that we would be considering would be not really the correct product as we multiply. That's why I have here arrow, which would mean imply rather than equals, because they will not be equal this time. Let's see. So first we have 2 times 2, of course, that gives us 4. Next, 2 times 4, that gives us 8. All right. Next would be 2 times 3. I hope you can follow. That gives us 6. Now here, 2 times 7 is 14. We won't write or consider the correct product, which is 14, but we would split these two numbers or these 2 digits, and we will add each digit to our sum here. So meaning, instead of us adding 14, we would be adding 1 and 4. You see, that's why we cannot do our technique in UPC for this credit or debit card. So applying the same concept here, because 2 times 6 is 12, that's 2-digit, the product exceeds 9, we won't add 12, but we would add 1 and 2. There you go. So let's continue. Here the answer is 16, and we would not add 16, but we would do 1 plus 6. And lastly, we have here 2 times 1, which would be 2. There. Okay, this time we can say equals because we are now to we are about to calculate this. So again, we can do this manually, or efficient and effective way of doing that. I'll be having SciCalc here. So that's 4 plus 8 plus 6 plus 1 plus 4 plus 1 plus 2 plus 1 plus 6. Lastly, 2. Okay, that's 35. Let's, okay, let's have that one here. Equals 35. So as for add numbers, we have a partial sum of 35. Now let's do, or let's have this time even. Okay, as for even, we have 3, 5, 2, 1. Let's have that here. 3, 5, 2, 1. 3521 7908. 7908. Just have to add the numbers in even positions as is. So the answer there would be, let's have the help of calculator here. That's 3 plus 5 plus 2 plus 1 plus 7 plus 9 plus 0 plus 8. Okay, the answer is 35. So this is still 35. What are the odds? 35. So just like in UPC, once we have the partial sum here, we are to get the total sum. So we are to add 35 and another 35 here, partial sum for odd positions and even positions, and of course that would give us 70. Now just like in UPC, the total sum must be divisible by 10. Careful, because not algorithms should be divisible or with respect to the divisibility of 10. We have different modular number. We can have mod 10, mod 11, mod 12. So careful when you do research, double check what their n is or what their mod n is. So that's 70, and clearly 70 is divisible by 10. Therefore, this is a valid credit or debit card number. All right, so if you have some questions on how to do this, again, feel free to comment and I'll be more than willing to help you guys. All right, see you in my next videos, guys. Thank you.